Hello, everyone. We are back, and as promised, we're going to tell a fun story about beer today. But first, the real topic. What do we do when we have small sample sizes? We've been saying large sample size, large sample size, large sample size, but there are lots of times when we're going to have samples that are less than 30. So when you do, you're going to utilize essentially a student's t-distribution. Now, student is a pseudonym. What's a famous pseudonym that you know? For example, Mark Twain is a pseudonym for what? Samuel Clemens. Anyways, I love that. That's my one literature knowledge. No, not the only one, but anyways. Basically, is actually William Gossett. And William Gossett was working for Guinness Brewery. And Guinness Brewery was actually applying statistical analysis way ahead of its time. And obviously, they didn't want William Gossett publishing some of the trade secrets. And William Gossett did something very a little bit dangerous. I mean, again, very bold at the time, which is actually going ahead and proceeding with and publishing that regardless. So good for him. That's a very bold move. But yeah, excellent. Good for him. But anyways, it looks very similar to, again, this t-test or this t-metric should look very similar to our old z-value, but we have, again, that 1 over n value. Now, the assumption here is that, again, underlying population is Gaussian, but you see that there's going to be this new variable called nu, and that's going to be essentially our degrees of freedom. It's just going to be n minus 1. So t-distribution, again, it's going to be symmetric, total areas, unity. It approaches... Once we get greater than 30, they will basically be identical. And actually you can see that as t goes to infinity as well. For the t distribution, and we can see the table there, it's actually the area between t and t infinity. So unlike our z table, where we're going from 0 to the value of z, that area alpha is actually from t to t infinity. So again, we're looking at the value t will have a greater than that given in the table. So we can assert, and if we want to calculate confidence intervals, that's just going to be 1 minus alpha. Because again, we don't want effectively, if you're looking at a t table, it's really giving you effectively the area over here, but we want the area in here, so that's where the 1 minus alpha comes. And alpha is also referred to as kind of basically significance or level of significance. That'll be another term essentially that you'll see. So a level of significance will effectively refer to alpha. So a 5% level of significance will correspond to a C of 95%. So anyways, so for a two-sided confidence interval, we would just have this here. So the only thing that changes is that prefactor T alpha over 2. And again, if it's two-sided, and then we'll get into kind of left-sided. Again, you can see alpha as that level of significance here. So let's go ahead and calculate this with an example. So we're given basically 18 samples, which should nominally be 2 milligrams. You weigh them and we get the following results here. So actually we can kind of see and read in this PCM data set that we have available to us, luckily, thankfully. So let's go ahead and let's read in actually. And we can calculate this ourselves. Oops, just kidding. There we go. So let's go ahead and read in our values. So let's go to our files. Let's see, we have our PCM. So let's go to, I want to do open, actually not open, read underscore Excel. Actually, I'm going to do PCM dat read.excel and then pcm.xlsx. So we got that. So we should have, and we'll get PCM dat. We can extract hopefully all the data sets here. So here's our data sets. All right, excellent. So we can calculate the mean. So we can calculate the mean here. PCM there. We can also calculate what is our SD of PCM, PCM dat bracket 1 So we can get that. And now we have to choose basically our, so we could do plus our T alpha over 2 value. So one of the things we have to look at is what is actually the length of PCM dat bracket 1. So 18. So if I want to figure out my T value, we're going to have to go all the way down. All right. So we want T alpha over 2 nu. Nu is going to be n minus 1, so we said that was 18, so nu is going to be 17. So I'm looking at this row here, 17. And we're looking for a value of alpha over 2. So our alpha is our level of significance, which if we're looking for, what is the problem asking us for? I think it's a 95% confidence interval. 95%. So if it's 95% confidence interval, that means it's an alpha equal to 0.05. So we're looking at 0.05 divided by 2, which is 0.025 right here. So we're looking for a value of T of 2.110. So we can go ahead and we can do, look at the mean plus T alpha over 2, which is 2.110, times our standard deviation times this divided by square root of n, which is our length. So square root of the length of this. So that'll give us one bound, and this will give us our other bound. So you can do a minus. And if you just want to look at the plus or minus value, we can just pull out this value here. So there we go. So we can double check and look through our notes, make sure that's indeed the case. It looks pretty correct to me. 0.02 looks nice because this is 0.02 milligrams. Fantastic. So again, for small sample size, that would be our value. And you can see here when we go to infinity, if we look at a 95% confidence interval with that 0.025, look, 1.96. That's our value again. So we can go ahead and look at that. Now, you can also double check this, and we can actually look at this in R. We can look at, and import some back. We can look at mean CI. Oops, I think we may need to import some things here. Mean underscore CI, or mean CI. Let's just look at CI. Confidence interval. We should have a mean. We should have some values here. Maybe it's just little mean CI. My apologies for this, but it's important. So we don't need boot. But we can actually get this either way. And one of a better way to do it actually is from something called a t-test. So we can actually get t-test, and you can see some of the things that come up, come out from that. So I could look at my PCM. I could do t-test times PCM dat bracket 1, and you can see these are my confidence intervals there. So 1.898. We can look at and compare that just a little bit further. Oops. Let's go ahead. Let's go up just slightly. So let's look at that value. Looks pretty close. Again, there's going to be some a little bit off because, again, the way that we do the estimates. So this looks fantastic. And you can look at confidence intervals like that. But we have this thing called a p-value here. What is that? That's very interesting. And something called a hypothesis test. Well, you know when we're going to get to that in the next lecture. So good luck on your PSET 3 and PSET 4, and I'll see you in the next video. Thanks. Bye.